everyone. In the previous discussion, we understood about ring AB fusion and ring BC fusion, in which we utilized dicarboxylic acid. With the help of them, we synthesized various cycloketone system, and then further upon Clemenson's reduction, we got a compound called as deoxypyroacid. Now this deoxypyroacid and its conclusion, we could understand about the various ring fusion of AB system. Because the evidence was given through a coprostain structure. Now on the screen that we are observing is a coprostain structure. Now this coprostain structure, it gave an evidence that ring AB will have a cis fusion, and the other evidence was derived from lithocholic acid for ring AB fusion. Both these evidences, they said that ring AB fusion is cis. X-ray evidence of ring BC fusion, it said that there is a transfusion of ring BC. But naturally occurring system told that both cis and trans fusions are reported for ring A and B respectively. So in this particular discussion, we saw that ring AB system can both be cis fusion and trans fusion, and ring BC system has to be a transfusion, where the evidence was given by X-ray analysis. Now after looking at this analysis, now we have to look for ring CD. So in this particular discussion, we will be looking for a chemical evidence to demonstrate that ring CD fusion is trans. Now what we want to demonstrate is ring CD fusion is trans. For this, first we will take up compound number 1. We have already defined what is this compound number 1, and based on that compound number 1, we have tried to understand that from those compound number 1, various derivatives could be synthesized. In this particular system also, compound number 1, which is a cholesterol system, through which there will be a synthesis of deoxycholic acid. Deoxycholic acid is nothing but position number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. At 12th position, there is an introduction of OH. Rest all systems will remain same with the CH3 at the position number 18 and 19. That means we can see that the angular methyl groups are present, but there is a new introduction of OH at position number 12. Now this compound we will be naming as compound number 10. The name being deoxycholic acid. Deoxycholic acid has got at position number 3 OH from the cholesterol, and at position number 12 again OH, which will be synthesized. Utilizing this deoxycholic acid, which is compound number 10. Upon degradation of this deoxycholic acid, it gave a compound number 11. This means that there is a cleavage between ring C and D, giving me a dicarboxylic acid. This particular compound did not give a anhydride readily. That means if there is a presence of a dicarboxylic acid system, easily it should lose carbon, it should lose water, and an anhydride system should be synthesized. Generally when we look, if the position of the carboxylic groups are in one plane only, we can easily get a anhydride system. But what happened in this particular system is it did not give readily the anhydride system. But when the conditions were turned into in vacuo conditions, the anhydride 13 was synthesized. Sorry, the anhydride 12 was synthesized. Now Roman numeral 11 is a dicarboxylic acid, and under in vacuo condition the anhydride 12 was synthesized. This particular anhydride, this upon hydrolysis, this particular anhydride, which is compound number 12, upon hydrolysis yielded a dicarboxylic acid. Now the question is whether this compound number 13 that has been synthesized, whether it is similar to that of compound number 11. But as we can look from the structure and the position of these protons over here, here in compound number 11, the proton is below the plane, whereas in compound number 13, the proton is above the plane. Hence, we can say that compound number 13 and compound number 11, both are not similar to each other. This means that they are different from each other. Now, this will reveal something. This will give certain conclusion. This reveals that the anhydride 12 and the acid 13, they both must have cis configuration. That is, the anhydride system, which is this compound which will be having a cis configuration, and the compound number 13 both should have a cis configuration, because the anhydride system is now giving me a dicarboxylic acid system easily. But opposite of this is the compound number 11. That means it should have internal trans configuration. Why? Because it is not easily giving me an anhydride system. But under in vacuo condition, what is happening is this plane is getting changed. That is carboxylic system plane is getting changed, and the proton is now coming above the plane. In that condition, we can easily get compound number 13 or compound number 12 first, and then further compound number 13. So indirectly we can say that since compound number 12 and compound number 13 both are cis configuration, obviously compound number 11 should be opposite configuration, that is trans configuration. Therefore, this particular revelation that there is a trans configuration, it should say that the CD fusion is now trans to each other, because compound number 11 is a trans configuration compound. We can easily now connect it to the previous compound, that is deoxycholic acid, giving us the evidence that CD fusion is a trans fusion. So through this chemical evidence we could understand that CD fusion is a trans fusion. So what we do here is, first, we synthesize a deoxycholic acid, that is at position number 12 we introduce an OH. Then there is a cleavage between ring C and D, which is going to give me compound number 11. This compound number 11 is not easily giving me this anhydride. Rather, the condition should be converted to in vacuo condition so that an anhydride can be synthesized. Further, this compound number 12 easily upon the cleavage, it is going to give me a dicarboxylic acid, which is compound number 13. These two systems, that is compound number 12 and 13, both of them are said to be in cis configuration. But compound number 13 and compound number 11 are different from each other, giving us an evidence that compound number 11 is under a trans configuration. In turn, this tells that CD fusion is a trans fusion. So this is how we can give a chemical evidence that CD fusion is a trans fusion. So AB fusion can be both cis and trans. BC has to be a system like we understood from a X-ray analysis that BC system also has to be a trans fusion, and then CD system, through this chemical evidence we could now understand that a CD system is also a trans fusion. So in this way we could complete the nucleus now. Then now we need to understand hydrogen atom at position number 9. So when I count 1, 2, 3, 4, 5, 6, 7, 8, 9. The hydrogen atom at 9. The X-ray analysis showed that the proton at C9 is trans to CH3. Can we not observe here that this proton is below the plane, whereas the CH3 at position number 10 is above the plane. Now in this way we can understand that the position number 10 but the CH3 is given as 19th. That means at position number 10 and position number 9 the methyl group is trans with respect to the proton. Now this has been given through an X-ray analysis. This is a strong analysis telling that C10 and C9 groups, both of them are trans to each other. Now NMR evidence also gave that C10 and C13 methyl group. Now C10, this is the C10 methyl group and this is the C13 methyl group. Both are cis. Now this evidence was given by NMR system. So the evidence that we got in this particular system is through X-ray analysis. It was said that proton at C9 is trans to CH3 at C10. We can look here in the structure. And both the methyl groups, that is at position number 10 and position number 13, both the methyl groups are cis. Next comes the NMR evidence. Angular methyl groups, they undergo coupling with certain protons on the steroid nucleus. Now where are these angular methyl group? They are at position number 10. Now when I say this position number 10, I should now consider that there are various angular methyl groups, that is at position 10 and position 13. But right now I am just considering position number 10 methyl group. Now this can couple easily with C1 carbon. It can couple easily with C5 and C9. CH3 of the position number 10 can couple with C1 proton, C5 proton and C9 proton. If the C10 methyl is freely rotating, that means if it is freely rotating, it can couple with C1, it can couple with C5 and it can couple with C9 proton respectively. Now, this will happen if ring AB is having a transfusion. This is going to happen if ring AB is in the transfusion. Now AB should be in the transfusion. Then this methyl group is going to have a free rotation. It is going to couple with 1, 5 and 9 respectively. 1, 5 and 9 proton respectively. But if the AB fusion is cis, now only this methyl group can couple with C9 proton only. It cannot couple with the C1 and C5 proton. So this is the condition. If ring AB is a transfusion, this methyl group will freely rotate and it is going to couple with 3 protons. Whereas if ring AB fusion is a cis fusion, then the methyl group is only going to couple with the C9 proton. If at all it is a transfusion, then the NMR peak width, if it is a transfusion, the NMR peak width of the CH3 will be large, and if it is a cis fusion, the NMR peak width of the methyl group will be small. This is because if there is a transfusion, it is going to couple with C1, C5, C9 protons. Whereas if it is ring A and B are having a cis fusion, it is just going to couple with C9 proton. This is how we get two different NMR in the system. So in this way we can try to understand about the various types of evidences that can be given through the NMR evidence, X-ray evidence for the ring fusion and the angular methyl group, how they can couple and how they can give me various NMR evidences. Through this, now we could come to a conclusion about the nucleus and their fusion, that is ring A, B, C, D, and finally the angular methyl group, how it couples with the different protons under different fusions. In this way, now we could complete the nucleus of the cholesterol system. Thank you.